Study power, note down. Power. After this, we'll do conservation of momentum. Okay, linear momentum. Okay. Where are others? They are coming. Okay. So the name of the chapter. What is the name of the chapter? Work, power, energy. But how we are studying? Work, energy, power. Correct? Sequence. Work, energy, power. Okay. Let's take one example. Let's take one example. Suppose there is a car. Suppose there is a heavy car. Engine is not working. Engine is not working. Engine fail. Okay. So one person is pushing the car. One person is pushing the car from behind. One person is pushing the car from behind like this. Okay. So car will move slowly, little bit. Suppose the car is moving with what speed? 1 meter per second. But person has to apply how much force? Say 1 Newton. Just for example, person is applying 1 Newton. As a result, car is moving. Correct? It means person is doing work or not? Yes, work is. Person is doing work because person is exerting force. Displacement of the car will be there. How much displacement? Tell me. S is equal to ut plus half a t square. Correct. A is 0. A is 0. Car is going slowly with 1 meter per second. Correct. So S will be equal to ut. Right. So displacement will be there. Displacement. Force is there. Correct. So work done is there. Work done is there. What is the formula for work done? Fs cos theta. So car is moving with constant velocity. Okay. Force is there. So work done is there. Correct. So we will say the person is doing work. Person is doing work. So how much work per second? How much work per second? If we calculate this, then this is known as power. How much work per second? That is known as power. So let's understand using this example again. So it is going with a constant speed. The car is going with constant speed. So can I say the person is not doing any work? Person is not doing any work. Tell me. If car is going with constant speed, can I say person is not doing any work? It is rough surface. It is rough surface. Tell me. Rough surface means car can move by itself or you have to push it. You have to push it. So it is rough surface. So it cannot go. You have to push it. Correct or not? Now you are pushing it like this. So speed is constant. Speed is constant. So friction is doing work. What is the direction of friction? Opposite to motion. And what is the direction of your force? What is the direction of your force? Right word? Are you getting or not? And what is the direction of displacement? Displacement is also right word. So you are doing positive work, friction is doing negative work. See, friction, force is right side, displacement is right side, friction is left side. So capital F is doing positive work, and small f is doing negative work. Are you getting? But velocity is constant. Velocity is constant. So what is the change in kinetic energy? Velocity is constant. Velocity is constant like this. Velocity is constant. So change in kinetic energy is 0. So what is the total work done? Ah, yes, yes. What is the total work done? Tell me. Total work done 0. Change in kinetic energy 0 means total work done what? 0. What do you call this theorem? Change in kinetic energy is total work. What do you call this? Work energy theorem. So according to work energy theorem in physics, total work done is equal to change in kinetic energy. So suppose this object is going with constant speed. Suppose it is moving with constant speed like this. So speed is constant, so change in kinetic energy is 0, so work done is 0. Capital F. Capital F. This is capital F. I am exerting what force? I am exerting what force? Capital F. Friction is how much? Small f. So velocity is constant means both are same or different? Velo velocity is constant. Same, correct. Equal. Suppose I am exerting 1 Newton, so friction is also 1 Newton. So suppose capital F is doing plus 1 joule. Capital F is doing plus 1 joule. So how much small f is doing? Friction is doing how much more? Minus 1 joule. Correct? So total work done is 0. But actual work done is there. Capital F is doing work. Friction is doing negative work. Are you getting or not? Okay. So when we say work is done, how much work is done per second? Okay, like 1 joule per second or 2 joule per second or 3 joule per second. That is known as power. That is known as power. So here, suppose let's do one question. Suppose let's do one question. So you basically you write down power is equal to work done upon time. Work done by time. You divide the work done by time, you will get power. Okay. So suppose this is the block of mass m. Capital F is there to move the block. Okay. We have the best example here. Okay. This is the block. I am moving this block like this. I am moving this block. Okay. So I am doing work. I am doing positive work. Friction is doing negative work. Okay. So how much is so suppose velocity is constant v. So in time t, you tell me how much is displacement. Velocity is constant. Velocity is constant. Tell me in time t how much is displacement. Tell me. Vt. Very good. So how much is work done? External work done. Tell me how much is external work done? Capital F into S. So F V T. So in time t, how much is power? In time t, power delivered. Power delivered is equal to work done by time. So how much is work done? FVT, and time is t. T cancel. So power is equal to FV. Power is equal to FV. Okay. So note down. Power is equal to FV. So suppose you are exerting force F and friction is also there. Friction is also there left. So note down. So how much power you are delivering? External agent. How much power external agent is delivering? Delivering means transferring. FV. Okay, understood? Force into velocity. Yes, yes. Force into velocity. Now, suppose if I ask a small child will come. It will slowly it will move the chair, right? Slowly it will move the chair like this. So what is less? What is less? Force is less. Velocity also less. Less velocity. correct? But now big person will come, so it will move very fast. Now what is difference? Now what is difference? Speed is more. More speed means velocity more means power is also more. Force is also more. Correct or not? So power, this formula you memorize. Okay, force into velocity. If you exert greater force, so more power. If you velocity is more, so more power. Okay, clear? So write down one question. Suppose one object is truck, another object is car. Truck is moving. Now truck is massive, more mass, correct? So truck is moving with velocity 10 kilometer per hour. Truck is moving with velocity 10 kilometer per hour. Road is pushing it with constant force. Road is pushing it with constant force of 500 Newton. Road is pushing with constant force 500 Newton. Correct? Now next line you write down car. Car is moving with velocity. Now car is generally faster. Car is moving with velocity say 30 kilometer per hour. So it is constant. Okay. Road is pushing. Road is pushing it with 200 Newton. 200 Newton. Find work done by road. Find work done by road per unit time. Work done by road per unit time in truck and car. Work done by road per unit time in truck and car. Okay, solve. Work done per unit time means what I am asking? Power. Okay. So I am asking power. Okay, solve. Work done per unit time. Note down. Work done per unit time means power. So what is the formula for power? Force into velocity. Okay, force into velocity. Okay, note down. Okay, solve. So how much force road is exerting? First you have to check that. So when you move, when you are moving, suppose I am moving, who is pushing me? Tell me. Who is pushing me? Is someone behind me pushing me? No. So who is pushing me? How I am able to walk? Huh? Yes? Friction force. Very good. So this surface is rough. Surface is rough. That's why I am able to walk. Okay. If surface is smooth, I cannot walk. Okay. Same thing with car and truck also. The tires. You have seen the tires of truck and car. So what is the role of engine? What is the role of engine? What engine is doing in the truck? It will rotate the tire. Okay, it will rotate the tire. Suppose this is the tire, so engine will rotate the tire. Suppose it is rotated clockwise. Engine is rotating the tire clockwise. So the lowest point will is moving where? Suppose it is rotating clockwise, lowest point is moving where? Right or left? Left. Very good. So lowest point is moving left. So friction will at right. Okay. Friction from road. Friction from road will at right side. Okay. So when tire will move, tire will rotate clockwise, the friction will act right side. So this friction takes truck, okay, it will move the truck, car, okay, are you getting? So, so it is the friction which is doing work. It is the friction which is doing work. So work done per unit time. Work done per unit time is known as power. So tell me how much answer. Tell me for truck. How much force road is exerting on the truck? 500 and constant velocity is 10 into 5 by 9. Correct? 10 into 5 by 9 meter per second. 5 by 18. Yes, yes, correct. So 10 into 5 by 18. 10 into 5 by 18. Okay, we can solve this. So 25,000 by 18. Okay, what is the unit of power? Watt. And similarly for car, force into velocity. Force into velocity. So 200 into 30 into 5 by 18. Right. So this will be 5 into 2, 10. So this will be 30,000 by 18. 30,000 by 18. Okay. So this is the power. So you just remember what is work done, who is doing work, force is doing work. Who is delivering power? Force. Force is delivering power. Remember this. Okay. Who is doing work? What is the answer? Force. Force is doing work. Who is delivering power? Who is delivering power? Force. Answer is force. Who is delivering power? Answer is force. Okay. So force is doing work. Force is delivering power. Like for example, this object is there. So this gravity. Now gravity will pull it down. Why it is falling down? Why it is falling down? Gravity. So who is doing work? Displacement where? Displacement. Downward. Force where? Force. Downward. Which force? Gravitational force. So gravitational force is doing work or not? Yes. What is the force? How much force? Mg. Mg. Suppose displacement is S. So how much is work done by gravity? Mgs. Correct. So gravity is doing work. Gravity is a force. Gravity is doing work. Correct or not? It is taking some time also. Suppose if I release from here, so it is taking some time from to come from here to here, or immediately it is coming like this. It is taking some time, right or not? Right now it is here, after some time it is here. Are you getting or not? Time also it is taking. So work is also done with respect to time. Okay. So work done per unit time, that is known as power. If more work is done, if work done is more per unit time, so power is more. So suppose 1 joule is work in 1 second, and 2 joule is work in 1 second. So what is the power in this? 1 joule per second, that is known as 1 watt, and 2 joule is work is done in 1 second. So 2 joule per second, so this is 2 watt. So what do you mean by 10 watt? 10 watt means 10 joule per second. 1 megawatt, you know megawatt? Megawatt. So 10 power 6. 1 kilowatt, 10 power 3 watt. 10 power 3 watt means 10 power 3 joule per second. Megawatt means 10 power 6 watt. So 10 power 6 joule per second. Okay. So 10 power 6 joule per second. Note down. So this is 10 power 6 joule per second. Kilowatt is 10 power 3 watt. 10 power 3 joule per second. So remember, work done upon time. And now we have one more. Now let's do. Okay, you just write down these units. Then Okay, note down. Megawatt, kilowatt. So when I say work done per unit time, okay, so it is known as rate of doing work. It is known as rate. It is known as rate of doing work. Rate of doing work. When I say rate, rate means we compare with time. So suppose uh, when I say speed, what is a speed? Tell me, what is a speed? Rate, rate at which, rate at which distance is covered. Distance is covered. So suppose 2 kilometer is covered. 2 kilometer is covered in 1 minute. So what is the speed? 2000 by 60 meter per second. Correct. If 2 kilometer is covered in 2 minutes, so what is the speed? 2000 by 2 into 60 meter per second. Correct. So this is the speed. If more distance is covered in same time, so speed is more. So that is speed. It is rate. Similarly, we have power. Power is equal to rate at which work is done. Power is equal to rate at which work is done. Okay, rate at which work is done. If more work is done per second, so more power. Less work is done in same time, so less power. Now, so we have two types of power. Like speed, also two types. Instantaneous speed. What is the formula for instantaneous speed? Dx by dt. Very good. And what is the formula for average speed? Delta x by delta t. Correct. Total distance by total time. So I'm not revising this. Okay, we have done this. So power also two types. So note down. Power has two types. Note down. Power, two types of power. Note down. Two types of power. What are the two types of power? Average power. Note down. Average power. So what is the formula for average power? Total work by total time. Total work by total time. And total work can be done as change in kinetic energy. Okay, change in kinetic energy by total time. And second is instantaneous power. Instantaneous power, what is the formula? dw by dt. dw by dt, rate of doing work. Okay, now so dw can be written as fds cos theta. So dt, so ds by dt will be v. So what is the formula for instantaneous power? Fv cos theta, because dw is equal to force into small displacement into cos theta. Okay, so small displacement by small time, what is this? Velocity. So Fv cos theta. Instantaneous power is Fv cos theta. Average power is total work done by total time. Total work done, what is the formula? Total change in kinetic energy. Okay, change in kinetic energy is total work done. Good. So remember this. Okay, fine. So two types of power. So let's do one question based on this. Two cars are there. Question. Two cars, one and two. Two cars are there, one and two. Mass of car one is say 1000 kg. Mass of second car is 1500 kg. Car one picks up speed 0 to 36 kilometer per hour in 10 seconds. Car 2 picks up speed 0 to 72 kilometer per hour in 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 15 seconds. In 15 seconds. Okay. Which car has more power? Which car engine? Which car engine has more power? Which car engine has more power? Okay, so we know that car is there, so engine is there. Some cars are very powerful, like Ferrari, right? Why Ferrari is famous? Ferrari. Why Ferrari is famous? Tell me. They are very powerful. Engine is very powerful. Correct. One more car is there. Lamborghini. What you call? Lamborghini. Okay. That one more car is there. That Rolls Royce. Huh? Rolls Royce. Okay. Why they are very famous in the world? Because engine is highly power, more power. They go up to 500 kilometer per hour. Okay, speed 400 kilometer per hour. Racing cars, correct. So we can compare the power. We can compare the power. See, what formula you will use? Tell me. Mass is given. So average power you calculate. What is the formula for average power? Average power. What is the formula? Tell me. Change in kinetic energy by time. Okay, calculate. What is the average powers delivered by car 1? What is the average power delivered by car 1? What is the average power delivered by car 1? Tell me. Okay, calculate. Power delivered by car 1 is equal to change in kinetic energy. Initially 0, okay? Initial 0. Final speed 36. So you can convert this in meter per second. So 36 kilometer per hour is in meter per second how much? 36 into 5 by 18 how much? 10, right? 72 kilometer per hour in meter per second how much? 72 into 5 by 18 how much? Tell me. It is 2 times 20. So what is the kinetic energy, final kinetic energy of car 1? Final kinetic energy of car 1, tell me. Half m p square, final speed, correct? And initial kinetic energy of car 0 divided by how much time? 10 seconds. Okay, calculate. Okay, so 100 by 2, so 50 into 100, so 5,000 watt. 5,000 watt. Now calculate power delivered by car 2. Power delivered by car 2, tell me. Power delivered by car 2. So half mass is 1500, final speed is 20, minus initial speed is 0. So initial kinetic energy is 0 and time taken is 15, correct? So this 15 and 15 cancel. So this is 100 by 2, 100 by 2 into 400. Okay, 20 square is 400. So this will be 2 times. So 20,000. 20,000, correct? Check it. 20,000. So which has more power? Second car. Second car has more power. Clear? Second car has more power. 4 times. Power of second car. Power of second car is 4 times power of first car. Okay, clear? So mass is also important. Because change in kinetic energy, mass is coming. Only speed, you don't see only speed, you have to see mass also, correct? Because kinetic energy depends on mass, correct? Kinetic energy depends on mass. Okay, so this is one example. So you see, you don't see speed only, you see mass also. Like truck, generally which has more power, truck or car? Truck has more power, but which has more speed? Car, correct? So but truck has more mass, correct? So when you compare the power, you have mass also you have to consider. Okay, how much mass, correct? Okay, so let's take a toy car is there. A toy car is 1 kg. It is picking up a speed 2 meter per second in 2 second. So what is the power? Half m v square by 2. So how much is power? 1 watt. Okay, toy car is there. This is the toy car. This is also toy truck. Now truck is more mass, say 8 kg, 8 kg truck, but it is not going more speed. It is going only 1 meter per second in 4 seconds. In 4 seconds. So now you tell me how much is power? Half m v square by time taken. So how much is power? 1 watts. Okay, so both have same power, correct? Both have same power. The problem, why both have same power? Because speed is more. For car speed is more, but for truck speed is less. But at the same time, truck has more mass. Okay, truck is more mass, car is less mass. Okay, so same power. Okay, if you change the mass of truck to 16, if the mass of the truck is 16, suppose 16 kg, then what is the power of truck? Half into 16 into 1 square divided by 4. Then what is your answer? 2 watt. Okay, so power of truck is 2 watt. Okay, clear? So toy car. So remember this, change in kinetic energy per unit time is equal to what? Power, average power. Okay, okay, next we'll do some more questions. Let's do power of gravity. Average power, note down, average power of gravity. Average power of gravity. Average power of gravity. So note down, a ball of mass 100 gram, a ball of mass 100 gram dropped from height, 20 meter. A ball of mass 100 gram dropped from height 20 meter. Find power delivered. Find power delivered by gravity. Find power delivered by gravity till it reaches ground. Till it reaches ground. Find power delivered by gravity till it reaches ground. Suppose this is the ground. So this is like this. Okay. So this is 20 meter. So what is the power delivered by gravity? So how to solve this? mgh, very good. So work done per unit time, you can use this, work done upon total time. Work done by total time. How much work done? mgs or mgh. So work done is mgh. Now time taken, how will you calculate time taken? You can use s is equal to ut plus half at square. U is 0, it is dropped, for u is 0. And what is the s value? 20 downward. And acceleration value minus 10. Acceleration is minus 10, correct? So minus minus cancel. So 20 is equal to 5t square. So t square is equal to 4. So how much time? 2. So put it here. So mgh by 2. Okay, mass you can put 0.1. Mass is 0.1 gram into kg. So 100 gram is also 0.1 kg. So 0.1 into G value 10 and H value is 20 divided by 2. Time taken is 2. So this is 1 into 20 by 2. So what is your answer? 10 watt. Okay. 10 watt. So note down. So power delivered by gravity. So what type of power is this? Average or instantaneous? It is average. Okay, because time is there. Till it reaches ground means duration is there. Duration of time is there. Duration of time. In time duration, when duration is there, 1 minute, 1 second, 10 seconds, 1 hour. Okay, time duration is there. So we calculate average power. Okay. So after what time it is hitting the ground? 2 seconds. After 2 seconds, it is hitting the ground. If I ask, so that is average power. Okay, average power is duration of time, like 0 to 2 second. 0 to 2 second is the duration of time, and what is the average power? If I say instantaneous power, find, next question you write down. This is first question. This is second question. Find instantaneous power. When ball is at height 10 meter. Find instantaneous power delivered by gravity, because the stone is going down because of gravity. Okay, stone is going down because of gravity. Okay, so stone is going down because of gravity. So what is the initial velocity of the stone? Initial velocity 0. And what is the height? What is the height? What is the height? It is 20. What is the initial height? Initial height 20. So this is 20 meter. This is 20 meter. So initial height is 20 meter. Now it is dropped. So as it is coming down, speed is increasing. So when it is at 10 meter height, what is the speed? First to calculate this, tell me what is the formula for this? When it is coming down, tell me square root of 2g h. How much it is falling? How much it is falling? 10 meter. So what is the speed? Tell me. Root 200. So 10 root 2. So what is the direction of velocity? Downward. And what is the direction of force? Force is also downward. mg. So force is downward, velocity is downward. So what is the angle? Angle is 0. So what is the formula for instantaneous power? F cos theta. Okay, power is equal to F cos theta. Force mg into velocity. Okay, substitute the values. So how much is instantaneous power? Mass of the car, mass of the ball. Mass of the ball 100 gram. Mass is 100 gram. So 0.1 kg. Okay, so 0.1 into 10 into V, which is 10 root 2. So 0.1 into 10, 1. So 1 into 10 root 2. This is your answer. 10 root 2 watt. Okay. 10 root 2 watt. So 10 into 1.41. So 14.1 watt. Okay. 14.1. So watt. So when it is at height, at, when you see at in the question, at, At means what type of power? Instantaneous. Okay. In, when it is written in 10 seconds, in 2 seconds, till it reaches ground, what type of power? Average power. Okay. Average power. Okay. What is the power at 0 seconds? What is the power delivered by gravity at 0 second? 0. So instantaneous power is increasing, correct? Because force is constant. Force is constant, but velocity is increasing. As the ball is going down, as the ball is going down, velocity increasing. So power is increasing. Instantaneous power. Okay, instantaneous power is increasing. Okay, clear? So we have best example, gravity. Okay, so you drop any ball, the speed of the ball is increasing. So gravity is doing work. Okay, so when you consider height, time duration, so you can calculate average power. When at particular instant, here or here, here or here, at particular point, what is the velocity? Then that is, and what is the force? So force into velocity, that is instantaneous power. Instantaneous power. If I ask what is the instantaneous power when it is touching the ground, so with what speed it is touching the ground? What is the speed of a strike? Root 2 gh. So how much? Root 400. So 20, correct? So suppose third question I am asking. Third question. Find instantaneous power. Find instantaneous power just before. Find instantaneous power just before hitting the ground. Find instantaneous power just before hitting the ground. Find instantaneous power just before hitting the ground. Just before it is hitting the ground. It is hitting the ground. Just before means like here. Just before it is touching the ground. So what is the speed when it is touching the ground? What is the speed? 20. So what is the instantaneous power? Force into velocity. Correct? Cos theta is 1. Cos theta is 1, right? When it is touching the ground, what is the direction of velocity when it is touching the ground? Downward. And force is where? Force. Downward. So theta is what? 0. Cos 0, 1. Good. So tell me, calculate. So 0.1, mass is 0.1 kg, gravity 10, velocity is 20. Okay. So 1 into 20. So 20 watt. Okay. So instantaneous power and average power, remember. Okay. Instantaneous power means force into velocity, remember. Force into velocity into cos theta, that is instantaneous power. So power has only two formula. What is the formula for average power? Total work done by total time. What is the formula for instantaneous power? Force into velocity into cos theta. Okay, clear? Okay, fine. Good. Now let's do some differentiation type questions. So x is equal to t cube. Next question write down. X is equal to t cube. What is the mass? Suppose 2 kg. Mass is 2 kg. Find power at 2 second. How to calculate this? Find power at 2 second. Now at instantaneous or average? Instantaneous. What is the formula for instantaneous power? F cos theta. So cos theta is 1. Okay, cos theta is 1. So what is the formula for instantaneous power? Fe. F is equal to ma, mass into acceleration, and acceleration is dv by dt. Very good. Okay, now calculate v. X is given t cube. So what is v? 3t square. So v is equal to 3t square. Now calculate acceleration. What is the acceleration? 6t. So put it here. This is acceleration. So m into 6t into v. V is 3t square. So what is the average power? Sorry, what is the instantaneous power? 18 18 m t cube. 18 m t cube. Mass is 2 kg. Time is what time I have given? 2. So 18 into 2 into time is also 2, 2 cube. So 18 into 2, yes, correct. This is 2 power 4. So this is 16. 18 into 16. Okay, clear? So this is your answer. So 48, 10, okay, 18, it's 288, right? So your answer is 288 watt. Okay, so note down 288 watt. So differentiation, use differentiation. X is given t cube, so mass is given, so find power at 2 second. Okay, use this FV, MAV, m dV by dt into V, m dV by dt into V. Okay, clear? Okay, I can give root t also. Suppose if I am giving like this, x is equal to root t, find mass, mass is given say 10 kg, mass is given 10 kg, find power at 4 seconds, find power at 4 seconds. Now you solve. Now x is equal to root t. So what is the differentiation? Suppose t power 1 by 2, x is equal to t power 1 by 2. So what is the differentiation of root t? 1 by 2 t raised to 1 by 2 minus 1. So 1 by 2 t raised to minus 1 by 2. T raised to minus 1 by 2 means 1 by 2 root t. Correct. Good. So when x is equal to root t, so velocity, this is velocity. So velocity is equal to 1 by 2 root t. Velocity is 1 by 2 root t. So what is the power? Fv. Okay, cos theta is 1. Cos theta is 1. So Fv. So Ma. F is Ma, and A is dV by dt. Again you differentiate again. So this okay, differentiate this. So how will you find A? Again differentiate this. So 1 by 2 into t power minus 1 by 2. What is the differentiation? T power minus 1 by 2. So is minus 1 by 2, t power minus 1 by 2 minus 1. So minus 1 by 4 into t raised to minus 3 by 2. Correct. Minus 1 by 2 minus 1 is 3 by 2. T power minus 3 by 2. Okay, t power minus 3 by 2. So this is acceleration. So you can write acceleration as acceleration is minus 1 by 4 t power 3 by 2. So minus 1 by 4. Now t power 3 by 2 means what? Okay, t power 1 by 2 means what? Root t. And t power 3 by 2, what is that? T into root t. Very good. T power 5 by 2 is what? T square root t. Okay, clear? You remember this. So t power 7 by 2 will be t cube root t. Okay, so here we need t power 3 by 2. T power 3 by 2 is t root t. So t power 3 by 2 is t root t. This is acceleration. This is acceleration. Now substitute here. So mass is given as 10 kg. Come here. This is the power. Okay, clear? X is equal to root t. So velocity is this dx by dt. So that is the velocity. Okay, 1 by 2 t raised to 1 by 2 minus 1. So 1 by 2 t raised to minus 1 by 2. 1 by 2 root t. So now again solve acceleration. So substitute here. What is the power? 10 into a. What is a? Minus 1 by 4t root t. Okay, t is there. This is t. Okay, then velocity, again velocity substitute 1 by 2 root t. 1 by 2 root t. Okay, carefully you solve. So your answer is plus or minus? Minus. So minus 10 by minus 10 by 8 t, and this root t into root t, it will be t, correct? So minus 5 by 4 t square. So minus 5 by 4 t square. Time is given as 4. So minus 5 by 4 into 4 square. Correct. So yes, tell me. 64. 64, yes. Minus 5 by 64. Clear? Are you getting? Your answer is negative. Okay. One option will be 5 by 64 also. You know it, right? One option will be minus 5 by 64. Are you getting or not? You're doing calculation. Okay, you forgot minus. You will take this. Right or not? So silly mistakes. Okay. So carefully you have to solve. Okay, fine. So instantaneous power over. Now little bit fast I am going. Okay, syllabus we have to finish. You practice these type of questions. I will revise it again. Okay. Sunday also I am planning extra class. So morning I will come. Okay. So okay, fine. So power. Let's do one more question. Last. Then I will start momentum conservation. So just remember. Okay, so variety of questions you have to solve. Okay, books you take books. DPP also I am giving. Okay, practice. Power is very important. Power is very important. Okay, I am finishing in less time, but it doesn't mean it is a not important topic. Okay, you practice it. Okay, DPP also you will get. Okay, fine. Now next question you write down. Now I am giving power. P is equal to 2t. Now this is integration. Power is equal to 2t. Mass is 2 kg. A toy car start from rest. A toy car start from rest and find its speed. Find its speed after 2 seconds. Find its speed after 2 seconds. Find its speed after 2 seconds. What is given? Power. What is given? This is what type of power? Instantaneous or average? Instantaneous. This is instantaneous power. This is instantaneous. Instantaneous power. Okay. So this is instantaneous power. Now, what is the formula for power? Tell me. Force into velocity. What is the formula for force? Ma. And what is the formula for A? dV by dt. Okay, good. So power is equal to mv dV by dt. Okay, so you can use this formula here. Now substitute here. Power is equal to 2t. So 2t is equal to mass is also 2. 2v dV by dt. 2 to cancel. So what is v dV? What is v dV? T dt. So v dV is equal to T dt. Now integrate on both sides. Integrate on both sides. Integrate. So tell me, how will you write? Now integrate on both sides. Integration of v dV is equal to integration of T dt. When time is 0, what is the speed? When time is 0, what is the speed? Time is 0, what is the speed? 0, good. After time t, what is the speed? V. After time t, what is the speed? V. Then we'll put t equal to 2, we will put, okay, they are asking what? Find the speed after 2 seconds. Okay, so initial time 0, initial speed 0, final time t, final speed V. Okay, fine. Now integrate. What is integration of V dV? V square by 2. So V square by 2 limits 0 to V. Good. Then t dt, what is the integration? T square by 2. Very good. Okay, 0 to t. Okay, now upper limit, lower limit substitute. V square by 2 minus 0 square by 2 is equal to t square by 2 minus 0 square by 2, correct? So what is V square by 2? T square by 2. V square by 2 is t square by 2 to cancel. So V square is equal to t square. So how much is V? T. V is t. So note down. So once again I will check. So power is given 2t and power is mv dv by dt. So 2t is equal to mass is 2v dv by dt. So t dt is equal to v dv. So t is v square by 2. V square by 2 is equal to t square by 2. The limits 0 to t and 0 to v. Okay, correct. So note down. So v is equal to t. So your final answer is v is equal to t. Now at what time I am asking speed? Find its speed after 2 seconds. So you substitute here. So at 2 seconds, speed is equal to t. So 2 meter per second. After 2 seconds, speed is 2 meter per second. So, okay, v is equal to t. So this is integration. When power is given, I am asking speed. So what you are using? Integration. You are using integration. So you can note down one short trick. So power is given, you are asking, you are finding velocity. Then velocity given, you are finding position x. Position x. So you have to use integration. Okay. So power is given, velocity asked, integration. Velocity given, position asked, integration. Correct. Now position is given. Position is given. You have to find velocity. Then you have to use differentiation. You have to use differentiation. Velocity given, acceleration you have to find. So you have to use again differentiation. Okay. Then power you have to find, again differentiation. You have to use m dv by dt into v. So mav, correct? Mav. So when you use differentiation, position given, velocity asked, acceleration asked, differentiation. Okay, power is equal to mav. When you use integration, power reverse. So power given, what you have to find? Velocity, integration. Velocity given, position is asked, integration. Okay, clear? Remember. Okay, fine. So you have to practice. Okay, without practice, it will not work. Let's solve one more question. Note down, power is equal to t square. Power is equal to t square. If particle start from origin means what is the x value? 0. So particle start from origin with rest means initial speed is also 0. So find its position and velocity Find its position and velocity at 3 second. Find its position and velocity at 3 second. Okay, solve. What is the position and velocity at 3 second? What is the position and velocity at 3 second? So first you tell it is differentiation or integration. Integration. Okay, so you do like this. So power is equal to t square. Okay, start doing. I'm doing slowly, you do fast. So power is t square. Particle start from origin with rest. So initial speed is 0, initial position is 0. So power is t square. What is the formula for power? mv dv by dt is equal to t square. Mass is given, take mass as 2 kg, you take, no problem, mass is 2 kg. Okay, so 2 into v dv by dt is equal to t square. So v dv is equal to t square dt by 2. T square dt by 2. Now integrate. So now integration, you have to do integration on both sides. Integration on both sides. So you will write integration of both sides. Integration v dv is integration of t square dt by 2. So v dv, tell me v dv integration v square by 2. Good. Then you have on the right side t square dt. What is integration? T cube by 3. Good. T cube by 3. This 2 is there. 2 I taken outside. Okay. This 2 is outside. Now this 2 to cancel. So v square is equal to t cube by 3. Okay. Now this is v. So v is equal to 1 by root 3 square root of t cube. Square root of t cube means it can be written as square root of t cube means what? Square root of t square into t. So t root t, correct? Or you can say t power. You can say t power 3 by 2. So this is t power 3 by 2, or you can say 1 by root 3 into t root t. Okay, clear? So this is velocity. Now at what time I am asking velocity? 3 second. Now put 3 second here. So at 3 second, what is the velocity at 3 second? So 1 by root 3 into 3 root 3. Okay, root 3 cancel. So what is your answer for velocity? 3 meter per second. Okay, at 3 second, velocity is 3. At 3 second, velocity is 3. At 3 second, velocity is 3. Now let's do, so you look here. So this is velocity is this is velocity. Okay, so velocity is 1 by root 3 t power 3 by 2. Now I want position also. What is the question? Find its position and velocity at 3 second. Position means x, velocity means v. Okay, how to find position? What you write v as? What is v? Dx by dt. Very good. Dx by dt is 1 by root 3 t power 3 by 2. So, so dx is equal to 1 by root 3 t power 3 by 2 dt. Now integrate. Again you have to use integration. Integrate on both sides. Integrate on both sides. So integration of dx is integration of 1 by root 3 t power 3 by 2 dt. So what is initial time? When time is 0, what is position? See, 0. It is start from where? It is start from where? 0. Start. Time 0 means x 0. V also 0. So when time is 0, x is 0. After time t, position is x. Here also I have to do like this only. So same thing you are doing here also. Okay. Limits you can consider limits. When time is 0, velocity is 0. After time t, velocity is v. Okay, fine. So what is integration of dx? X. So 0 to x. So this is 1 by root 3. Now what is integration of t power 3 by 2? Tell me 3 by 2 plus 1 by 3 by 2 plus 1. Okay, solve like this. So 1 by root 3 t power 5 by 2. Good. 5 by 2. This is also 5 by 2. So 2 will go to the numerator. 2 by 5. And then root 3 is there. And t power 5 by 2 means t square root t. Good. Now at what time position is asked? 3 seconds. Okay, read the question again. So find its position and velocity at 3 seconds. So put t equal to 3. So at t is equal to 3 second x. Now this is x minus 0. So x minus 0 is equal to this 2 by 5 root 3 into t square 3 square root t root 3 root 3 cancel. So 2 by 5 into 9. So 18 by 5 meter. 18 by 5 meter. This is your answer. Note down. 3.6 meter. Okay, clear? Is it difficult? Note down, note down. Copy. Everyone copy this. Okay. You do it once again. Okay. Afternoon, evening, night time, early morning, you practice. So you have to practice it. Okay. Practice the maths. Little bit maths is there. Integration. It is easy chapter. Okay. Think like this. Power is easy or difficult? It is easiest. One of the easiest. Okay. Friction is difficult. Power is easy. Okay. So don't think it is difficult. Okay. Fine. Now just copy this. I'm just starting new topic now. Okay. Power is finished. Actually, one more question is there. Okay, so one tricky question. You want one tricky question? Okay, this is finished. Clear? No doubt. So x minus 0 is equal to 2 by 5 root 3, 3 square into root 3. Okay, root 3 cancel. So 2 by 5 into 9. So 18 by 5. Just last question. Then I will start momentum conservation. When you pull something, you have to exert force. Like for example, this block, this object is there. I'm pulling it like this. I'm pulling it like this. So why this block is going up? Why it is going up? Because of which force? What is the force acting? Suppose this is the block. You have connected it with a string. This is the string. Tension. So tension is acting upward. Mg is acting downward. So suppose it is going with constant velocity. Suppose it is going with constant velocity. A block of mass m is going with constant velocity. So it is going with constant velocity like this. So what is the work done by tension after time t? Work done by tension after time t. Tell me, what is the work done by tension after time t? Ts. Ts. What is the direction of tension? Upward. Displacement? Upward. So Ts cos theta, correct? So Ts. And what is S? Acceleration 0. Acceleration 0. So what is S? Ut plus half a t square. A 0. So Vt. Ut. Correct. U is V here. So TVT, correct? TVT. And how much? What is the value of T? Mg. So what is the work done by tension after T seconds? MGVT. Very good. This is the work done by tension after T seconds. This is the work done by tension after T seconds. And what is the instantaneous power? Instantaneous power of tension. What is the instantaneous power formula? Instantaneous power formula. Force into velocity. So what is the force here? Tension. And tension means mg. So mgv. So instantaneous power of tension is mgv. Okay. And what is work done by tension after time t? Work done by gravity after time t. Work done by gravity. Tell me. After time t, what is the work done by gravity after time t? Plus or minus? Minus. Good. Minus mg into s. So minus mg into vt. And what is instantaneous power of gravity? Instantaneous power of gravity. Tell me. Plus or minus? Correct. So Fv cos 180. Fv cos 180. Correct. Velocity is upward. Mg is downward. Velocity upward. Mg downward. So what is the angle? 180. So mg into v into minus 1. So minus mg v instantaneous power. Okay, clear? So that is instantaneous power. So it is going with the constant speed. It is going with constant speed. So that is instantaneous power. Now what is the difference if I pull it like this? If I pull it like this I pull. Constant velocity or acceleration? Acceleration. What is the initial velocity? 0. Okay, so velocity is increasing. Here velocity constant velocity, acceleration 0. So, okay, fine. These 4 things. Now solve the same question if initial velocity 0, but acceleration is there a. If you want, you can write here also. Block is pulled up with uniform velocity. 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 Okay, clear? Note down. Block is pulled up with uniform velocity. So tension and mg equal, velocity constant, acceleration 0. So work done by tension is Ts cos 0. T is mg. S is Vt. So mg Vt. Work done by gravity minus mg Vt. Instantaneous power of tension Fv plus positive. So instantaneous power of tension Tv. T is mg. So mgv. Okay, mgv. Instantaneous power of gravity minus mgv. Minus mgv. Okay. Okay, clear. Now you solve next question. Suppose the same block Same block I am pulling like this. What is the initial velocity? 0. Now I am pulling like this. So how much force I am exerting? F. And what is the acceleration? How much acceleration? A. Initial velocity? 0. Initial velocity 0. So what is the downward force? Tell me downward force. Mg. Upward force? F. Capital F. You can call tension also. You can call tension also. You can call tension also. No problem. You can write T or F. Anything you can write. Okay. No problem. F or T. Anything. So A is there. Acceleration is A. So what Newton's second law applies Newton's second law. Which is greater? T or mg? So T minus mg is equal to ma. So what is T? Mg plus ma. Very good. So what is T? M common G plus A. Correct. Good. This is tension. Now what is the displacement after time t? After time t, what is the displacement? Ut plus half t square. What is u? 0. So what is the displacement? Half a t square. Very good. So what is the work done by tension? Work done by tension in time t seconds. Ts. T. M into G plus A. S. Half a t square. Okay. Note down. Half a t square. Okay. A capital A, small a, anything. Okay. Fine. Work done by tension in time t. Now what is velocity after time t? Velocity after time t. V is equal to u plus at. What is u? 0. So what is v? At. U is 0. So what is the instantaneous power? Instantaneous power of tension. How much is instantaneous power of tension at time t? At time t, tell me. Fv cos 0. Tension is upward, displacement is upward. Now what is F? F tension. M into G plus A. And what is the velocity? At. So this is instantaneous power. Is it clear? Okay. So I will revise it. Okay. Just one more topic, a small topic I will do. Okay, fine. So this is power. Okay, power is finished. Okay, clear? Power is finished. See, it is easy chapter. You just remember average power and instantaneous power. Average power, what is the formula? Average power, what is the formula? Total work done by total time. Instantaneous power, what is the formula? Fv cos theta. Correct. Good. Okay. And suppose tricky question is there. Force is like this. V is like this. 60 degrees there. So what is the instantaneous power? Fv cos 60. Correct. Okay. Centripetal force. What is the direction of centripetal force? Towards center. Velocity tangential. What is the angle? 0. So what is the power of centripetal force? 0. Power of centripetal force is 0. Power of centripetal force is 0. Okay, because angle is 90. Okay, like you will get you study some books also, you will get these type of points. Okay, read NCERT also. It is easy. Okay, I will also revise. Power of centripetal force is 0. So quickly, I am starting new chapter, new topic, momentum conservation. Note down. Momentum. It is also easy chapter, very easy. It is momentum conservation. momentum conservation. Okay, momentum conservation means linear momentum. What is the formula for linear momentum? P is equal to mv. So we can apply collision, explosion. Okay, so collision is separate topic. I will do tomorrow or after the break. I will do collision. Let's do one question on explosion. So examples. First, you write examples of explosion. Examples of explosion. So bullet and gun. Initially, the bullet is inside gun. So this is bullet. Initially, bullet is inside gun. So mass of bullet is small m. And what is the mass of gun? Capital M. Correct. So when bullet is fired, now bullet is fired. So bullet will acquire momentum in rightward direction. Suppose the velocity of bullet is v1. So gun will recoil backward. The gun will recoil backward with speed v2. So what is the initial momentum when it is at rest? So initial momentum. What is the formula for momentum? Mass into velocity. So what is the initial momentum? Capital M into 0 plus small m into 0. Both are at rest. Both at rest. Now some chemical reaction going on, chemical explosion going on. Okay. So bullet is acquiring momentum where? Right side. So gun is acquiring momentum where? Left side. So what is the final momentum of bullet? What is the final momentum of bullet? Tell me. M into V1. What is the final momentum of gun? Minus capital M into V2. Are you getting? What is the initial momentum? 0, 0. What is the initial momentum of gun? 0. Bullet? 0. Both are 0. Why? Why initial momentum is 0? Rest. Okay. Now you fire it, chemical reaction going on, explosion going on. Okay. So bullet goes right side, gun will go left side. So this is known as recoil. This is known as recoil. Recoil of gun. Recoil of gun. So we can conserve the momentum. Okay. Why? What is conservation of momentum? Conservation means what is the initial momentum total? 0. So final momentum is also 0. So momentum conservation means initial and final are equal. Initial momentum is same as final momentum. Initial momentum is equal to final momentum. Okay. So initial momentum is equal to final momentum. So initial momentum is equal to final momentum. Note down. Initial momentum is equal to final momentum. Now you observe the momentum of bullet is initially 0 but finally positive, and gun initial momentum 0 but final momentum negative. Correct. So one is getting momentum right side, another is getting momentum left side. Okay, that's why it is conserved. That's why it is conserved. If you see the number line, suppose one is getting momentum plus 1, other is getting momentum minus 1. Initial 0. If one object is getting momentum of plus 2, so other will get momentum of minus 2. Okay. You can also say that initial momentum is 0, one object momentum is increasing, another object momentum is decreasing, correct or not? So conservation. Okay. So then you can equate it. You can equate it. So what is the initial momentum? 0 plus 0. So you write like this: initial and final are equal in vector form. So 0 plus 0 is equal to minus mv2 plus small m v1 plus small m v1. So capital M v2 is equal to small m v1. So what is the recoil speed? What is the recoil speed of gun? This is known as recoil speed of gun. Small m v1 by capital M. Small m into v1 by capital M. What is the relative speed? This is recoil speed. What is the relative speed? Gun is going where? Left. Bullet is going where? Right. So what is the relative speed? V1 minus V2 or V1 plus V2? V1 plus V2. Good. So relative velocity of bullet, relative velocity of bullet with respect to gun, relative velocity of bullet with respect to gun. So what is the formula for this? Velocity of bullet with respect to gun in vector form. What is the formula? Relative motion Vb minus Vg. And what is Vb? Bullet V1 plus V1. You can say I cap also. Okay, but I don't want to make complicated. Let's plus or minus. Okay, plus and minus. So what is Vb? V1 minus. And what is Vg? Minus V2. Very good. Minus V2. So what is the value now? V1 plus V2. This is known as relative velocity. Okay, clear? Relative velocity of bullet with respect to gun. Note down. So this is also known as muzzle velocity. This is also known as muzzle velocity. Muzzle velocity. So what is the formula for muzzle velocity? V1 plus V2. Formula for muzzle velocity V1 plus V2. Okay, clear? So you have a gun and bullet. You have a gun and bullet. It is very easy. You fire a bullet, bullet will go right side, gun will go, it is recoil. This is known as recoil. Recoil of gun. Okay, so gun will recoil backward. Okay, so you have this formula. Now V1 and V2, V1 and V2 are with respect to ground. V1 and V2 are with respect to ground. So let's do one numerical. Muzzle velocity means relative velocity. Remember, formula for relative velocity is V1 plus V2. And V2 is equal to mass of bullet by mass of gun into V1. This is the recoil velocity of gun. Recoil velocity of gun. So solve one question. Gun of mass 10 kg, gun of mass 10 kg has bullet of mass 0.4 kg, 0.4, okay. Gun of mass 10 kg has bullet of mass 0.4 kg. Now bullet is fired. Bullet is fired. with muzzle velocity, muzzle, okay, LEAL, okay, muzzle velocity 50 meter per second. Bullet is fired with muzzle velocity 50 meter per second. Find velocity of bullet and gun. Find velocity of bullet and gun with respect to ground. Find velocity of bullet and gun with respect to ground. Okay, so solve it. Find velocity of gun and bullet with respect to ground. Means what I am asking? Velocity of bullet means v1. I am asking, and what I am asking? Velocity, speed of gun. Okay, these are the speeds. Okay. v1 and v2 are speed. And what is given? What is given? v1 plus v2. v1 plus v2 is given. Muzzle velocity is given. So v1 plus v2 is given. Now what is the formula for v2? v2 is equal to small m by capital M into v1. What is v2? Speed of gun. Speed of gun. What is v1? Speed of bullet. Okay. So now m by m you put here, m by m. So what is m? Small m. 0.4. Capital M. 10. Good. So this will be 4 by 100. Okay, correct? 4 by 100. So this is v1 by 25. v1 by 25. So what is v1? What is v1? 25 v2. v1 is 25 v2. v1 is 25 v2. Now v1 plus v2. What is v1 plus v2? 50. So v1 plus v2 is 50. Now put v1 is 25 v2. 25 v2 plus v2 is equal to 50. So what is 26 v2? 50. So what is v2? 50 by 26. 50 by 26. 25 by 13. Okay, clear? So v2 is 25 by 13. So what is v1? Now come back here. So come back to this 25 into v2. So 25 into v2, which is 25 by 13. So this will be 625 by 13. Okay, clear? So what you are doing? What you are calculating? v1 and v2. What is given? What is given? Okay, v1 plus v2. Okay, so this is the formula. Okay, note down. So we'll continue this. Okay, 1 more hour I will teach. You take break 9 o'clock, 9:15. I will continue. Okay, 9:15 to 10. Okay, 10:30, 10:45. Okay, we'll continue. Okay, we'll continue. Note down.